Good morning, everybody. First off, I'm not feeling very well. So I'm just going to throw that out there now. Probably not going to be taking a lot of dabs today. Got this horrible allergies with like post nasal drip and just horrible. Horrible right now. So excuse me in advance. It just hit me overnight. Like I have no idea how. It's like one of those things where you're not sure if it's really bad allergies or if you're actually getting sick. So take it a little easy today. Oh yeah, this coffee's banging. This fly's gotta go. All right, so this fly really has to go. I can't concentrate with the fly buzzing around my face. Let's try to get our morning dab in, and then after I'm done snotting and sneezing and coughing everywhere, we'll go ahead and we'll jump into these Grafana labs, and I'll show you guys how to set everything up from start to finish. Yo, fly, just come on. I don't have energy for this. Like, no energy. I had to hit that nigga with the razzmatazz right now. Caught him sleeping on the work laptop. Get out of here. Yeah, that's fly. Alright. Some wedding crashers. Oh, I know it's gonna be sloppy now. Just feel it. Take a little dab. See, like I haven't even hit it yet, and I'm already like coughing mucus. So I know I'm about to choke on this dab. Cheers. Now you guys are probably like, well, why are you even dabbing? It's the only way I can get high. Edibles don't get me high. Ooh. Yep. That he do. Ooh. Oh my goodness. All right. That wasn't too bad. I've definitely had worse sick dabs. All right. As long as you can actually get the dab down. I mean, I've been sick sometimes where I go to take a dab and I'm like, I know I probably am not going to be able to do this, but I'm going to try anyways. You drop this goober, it starts melting, you start inhaling it, and you can't even get past the fucking melt before you're just coughing your ass off. And you're just like, well, Can't do anything about that. Ooh, excuse me. All right, so let's do it. Bring this over here. You guys aren't going to be able to see me. All right. So for those of you that don't know, and actually, hold on, let me make a little post real quick on Instagram, let other people know. What we're going to be doing today is we're going to be setting up a Grafana dashboard. And this Grafana dashboard is going to host all of the data. Excuse me. Systems, those. Type it all the way in. Shouldn't have to do that. YouTube.com/Solventless in case people don't know it. Okay, so Pinnacle is a grow room logging solution that I developed 100% from the ground up, and it's pretty much ready to be put out for testing. So I am setting up my own test unit, Lost Leafs, DSG Labs, and then I have 7 other testers probably that are going to be getting sensor nodes and brain units. The system has 3 parts to it: the brain, sensor nodes, and control nodes. Sensor nodes are exactly what they sound like. It's a hub where you could plug in 10 sensors. It communicates wirelessly back to the brain and sends the sensor data. Then you have the sensor or the control node. Control node is what you're going to use to control different devices in the grow room, such as fans, humidifiers, dehumidifiers, your HVAC, all of that stuff. Okay, so sensor node, control node, and then you have the brain. And the brain is a server that I built, um, and it will collect data from all your sensors, and it will also communicate back to the control modules to, do whatever it is that they need to do, whether it's just flipping on and off an outlet, or if it's some type of modular control as far as your dehu, right? Hot start delays, things like that. Do all types of stuff. So yesterday I was up till the very, 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 very wee hours of the morning, debugging our code and getting it deployed in my grow room. So early this morning, I went out there and I swapped out the sensor node. And from what I can tell, everything looks like it's running the way it should. And now it's time to build the dashboard. So before I get into building the dashboards, I thought it would be pretty cool for you guys to see some of the back end, the coding that takes place. Um, when this gets to public release, there's going to be fancy software over the top of this, like a nice blanket that makes it nice and easy for the users to interact with. But for now, everything is done through some semi-advanced coding. There's automation in the scripts to help the configuration for each one of these devices. They are wireless devices, so they do have to be programmed um, and set up with credentials for your Wi-Fi and for your database for the server and a couple other things. So the developer that I'm working with created a very, very nice script to make that super, super easy. And I figured it would be kind of cool to walk you through it. So, oh, let me shut my door over here. Sorry, wife. So, first off, this is a sensor node, one of them. One out of the first 3 that I had built. Okay, I have 7 more being built right now for my actual other testers, but for now, this is what we got. So, let me grab my other one. It's already open. And I'll show you. Now, this is not the final design. This is just a temporary project box, but it works really well. Okay. So what you see in here is a 100% custom proprietary circuit board that's been custom printed, and it's had a few additional things added on top, like a buck converter, this ESP32, this SDI board. So in the next iteration of this board, everything is going to be actually built in to the board. It won't need to be soldered on. It'll be actually in the board. So that's super exciting. But the rest of this is pretty much good to go for now. And there's a port coming off this ESP32 module, which ESP32 is just a wireless module. Okay. So it adds Wi-Fi to things, basically. If you get a special kind of ESP32, it can have programmable memory on it, and you can flash firmware to it. And that's essentially what we did. And we built our custom firmware, and that is what is running on this custom build. There's 10 SDI 12 stereo adapter ports here. These are using 3.5 millimeter TRS pens, or tip ring sleeve connectors. Okay. And you can connect up to 10 sensors to this, right? When you're going to program it, though, it needs to have a configuration for whatever sensors you're plugging into it. So let's say you have, this can hold 10. Let's say you had 5 Teros 12s and 5 PAR sensors for whatever reason. You would have to have a configuration file created for 5 Teros 12s, 5 PAR sensors, load it to this, and then you can go and plug this in with all your sensors, turn on the battery, and it'll start logging on its own. Anytime that you change the sensor configuration out, you have to change the configuration on the board. Our firmware has not gotten to the point yet where you can unplug one sensor type, plug in a different type, have this recognize the type of sensor that was plugged in, load its own configuration file, and then still keep sending data. So you have to load a new config, and then you can plug in your sensors. But you shouldn't be swapping your sensors out like that anyways to have to update the config. It should only be, in between grows, or really hardly ever. Excuse me. So now we're going to get into the nitty gritty. We're not done with the code yet, so I can't tell you how many lines in total. But there's multiple codes, so it's not really a good way to answer that anyways, because it's not just like it's one, code file. There's probably over 20 already between the different sensors we support, the different conversions that need to happen, and things like that. All right, so we're going to go ahead and jump into this now. Let's get on my work computer first. So, using a program called Thani, okay? So you could, all right, you can't see that. Okay. So all of this is just pretty much a conf.gen file here. Let me see. We're going to stop the script. And all of the values that you guys are going to see today are they're dummy values, basically, right? So as I go through and I set up these appliances, I have to keep in mind that these are going to be going out to different people. So people are going to have different Wi-Fi's, SSIDs and passwords. They're going to have different database names. They're going to have different everything. So everything that's in this right now is for our test unit that's set up on a test network. And so um, this is my GitHub repo. It's where all of the files for the project are kept, basically. And there's a configuration file in here that when we open it up, you can see some of the data here. Here's some of it. Okay. So we're going to go ahead and run this script, and I'll show you what the configuration file does. Okay. Select interpreter. We're going to go back to Thani. We will connect to MicroPython. So now the script is stopped. We're going to hit run, and voila. There we go. Pops up with my logo, SB&V, which this is soon going to change to P for Pinnacle. So we are configuring an SDI12 sensor node. I also have EZO02 and EZO-CO2 sensor nodes that are in development. Water feature 8 sensor node for monitoring your reservoirs, and then a pump actuator node for doing, pH dosing or auto mixing nutrients. Today we're messing with an SDI12 sensor node, so we're going to hit option 1, hit enter. Now, I have tools that will allow me to plug in all of my sensors to one little box and automatically create a configuration file, but I don't have the box put together yet. I have to finish the box. So we're going to do select sensors from a list. I know what my sensors are because I already programmed them, but essentially SDI12 sensors get what's called an SDI12 address. It's basically like a home on your street. There's a bunch of different homes that are all on your same street. They're all connected, right? The only thing that differentiates them so that people know which one is which is the numbers on the outside. The appearance is all the same. All the houses look the same. They all look like SDI12 sensors. But the address tells you what is what. So the first sensor that we're going to select is an Apogee, and it's this SI4H1, and it's basically a radiometer. Okay, so we're selecting sensor number 1. And what's the address? Well, I know my radiometer is at address R. So I hit R, enter. Now I'm going down to the next sensor. And we're going to go down this list. So the Apogee S2 is my PAR sensor. That's a number 2. And that address on that one is, you guessed it, P. Now it is case sensitive when you're using SDI12 addresses. You have 0 through 9 and A through Z, both lowercase and capitalized. So sensor number 3 is going to be the Atmos 14, which is from Meter Group. It's sensor number 3 on this list, and it's at address A. Are you catching my drift here? We've got radiometer at R, par meter at P, Atmos 14 at A. Can you guess what's next? We're going to be doing some Taros 12s. I have 6 of them deployed in the room, so we're going to be picking number 4, Taros 12. What's the first address on that one? You didn't guess it. It's number 1. Okay, we're going to do that again. Taros number 12 at address 2. Taros number 12 at address 3, Taros number 12 at address 4, Taros number 12 at address 5, and Taros number 12 at address 6. All right, and there's no more sensors. We just configured all of these Taros 12s, these number 4s, at address, well, 1, 2, 3, 4, 5, and 6, and then we had our radiometer, par meter, and atmos 14 at ARP. There are no more sensors to select, so we're going to choose option number 6, hit enter. Now, we're going into InfluxDB version 1 right now. I did experiment with running a version 2. However, version 2 had a lot of issues with just how the data was being sent to the system. So we stopped using InfluxDB number 2, and we're going to use number 1 for now, and we'll upgrade to V2 on my tester and run a backwards compatibility test to make sure that we can still query the data the way that we want. And Ginger Russ says no hot swap. Hot swap is in the work. It will be available soon. You can hot swap sensors. So let me correct you. You can hot swap sensors. If you have one Teros 12, and let's say it's at address 2, and that sensor goes bad, you can plug in another Teros 12 that's been configured with address number 2 and just completely swap it out while the code is running and everything. Won't damage the system whatsoever, and you can just do a direct replacement. So if you have a sensor fail, no, you don't have to reconfigure anything. You can just swap it out with another sensor that's already been given the right address. However, if you're changing out your configuration of sensors, then yes, you are going to have to generate a new configuration file at this time. We are working on a way to make it so that's automated, but that is a difficult process and it's going to take some time. All right. So we're going to go on to configure our dummy database here. We're going to InfluxDB v1. The Wi-Fi SSID is Pinnacle. The password is right there. We're doing a 20-second delay between points. The host is actually brain.home. And InfluxDB port 8086. The database is Pinnacle. Grafana is the user. Password on it is Pinnacle. And this config is for an ESP32. And we're going to call this SBNV flower.2. And do we want to conserve battery life by putting the unit to sleep in between readings? Yes or no? And sure, let's put it to sleep. And we're not going to overwrite this because I already have a proper configuration file done. But now you see this configuration file is done. When I plug in my sensor node to my laptop now, I'll get the option to transfer the file over onto the sensor node. And then whenever the sensor node powers on, it's going to read that configuration file and it'll boot up and start logging those sensors that we just configured, sending it to the database that we just set up. Okay? So now we're going to go on to the next part. Okay? The next part is going to be dashboard. Okay? All right. So you got your data flowing into your InfluxDB, and now you're like, what do I do? How do I get my data to show up in Grafana? How do I make it useful? How do I view it in a way that is going to help me? How do I get the pretty graphs? Right? Basically what everybody wants to know. Shit, I put the wrong one. All right, so we're going to start by going into, once Grafana, this is assuming you've already set up a data source in Grafana, okay? Hold on. All right. So in Grafana, you're going to go to create dashboard. Once you have this dashboard created, it's blank. You're going to have to go up here to add a panel. Now we can add an empty panel. And we're going to choose our InfluxDB data source. We're going to go down here to query A, and we're going to select measurement. Now, we are pulling from flower 1 right now. That is in the grow room currently. We want to pull from that sensor node where, and we can choose a couple different things here, where the address is, where the model is, or what the vendor is. So we'll start with vendor. And now you can see we have 2 different vendors of sensors available here, okay? Or we could go with model. And if we choose model, you could see all the different sensors of models, the models of sensors available. Teros 12, par meter, the radiometer, and the AMS 14. And then the other one is to just go by address. And we know all of our addresses are because we just programmed them. And so here they are. We know we're successfully getting data in from the sensor node because it's populating with these addresses that we created, okay? So if these did not populate in your selection, that means that data is not being sent into your database correctly. But alas, it is. So we'll go ahead and start with the Atlas. So we're going to choose address A. Now, there's several fields to choose from in your database that are measurements. You need to know which ones apply to your sensor that you're choosing. For the Atmos 14, it's a 4-in-1 temperature, humidity, barometric pressure, and vapor pressure sensor. So those are the 4 values that are going to go into this sensor. There are additional values that can go into this as well, like converted into degrees Fahrenheit. Now, you may be wondering, how do I know which sensor values to choose from, or the measurement values to choose from, rather? And it's simple. You can either look it up in the list that is going to be provided with the system, or you can literally just go through here and choose. And if you're choosing like angle on this Atmos 14, there is no angle option. So you're not going to get any data in the response. That angle is for the par meter, right? So if I were to change this over to P and leave that one as angle and now apply it, I'm going to have to save it. There we go. Now we've got angle data coming in. Okay. So we're going to change this back to Atmos 14. And we want, I don't care about atmospheric pressure. I do care about degrees in Fahrenheit, which I got to make sure that's the right one. Yep. Because degrees Fahrenheit is a converted value that could come from the apogee radiometer as well, right? All the values that come from the sensors are in Celsius, and so on the back end, we convert them to Fahrenheit for you guys. Okay, so this is Fahrenheit of the room. Pretty cool. We're gonna. I don't want to share it yet. We're gonna edit it some more, and I'm gonna. I'm gonna try to walk you guys through this as I do it, but keep in mind I'm gonna move a little bit quick here. So we know this is Atmos, and we're just gonna put room temp. Okay. So now we know what that one is. We're going to add an override field with name. Ooh. All right, query A. We're going to change that. We're going to add an override, and we're going to say that the unit is Fahrenheit. We're going to add another override property, and it's going to be soft minimum is going to be 0. Soft maximum is going to be 100. Meaning it's going to set the graph at those points, and it'll allow the plotting to go past them if the values go past them, but otherwise it's going to keep it at 0 and 100. So now we can track our temperature and we can see, hey, there's our temperature. Pretty cool. You see it says room temp now, and it has 73 Fahrenheit. So it shows the actual unit of measurement. We're going to continue to edit this panel. We can go ahead and change the name of this panel to flower room, because that's what it is. We're going to add a legend in the form of a table. And we're going to choose last, minimum, maximum, and mean. We're going to choose to have nice curved lines. We're going to connect null values. And all right, and then we're going to go ahead and add more queries to this. So we've got our room temp here. We're going to go ahead and select some more data. So we're not done with that Atmos 14 yet. We still want some more information from it. And we got temperature. I would like humidity. So hello there, relative humidity. Give me that. I'm going to call that RH. And we're going to hit save. And there we go. Our relative humidity popped up. And if we want to go ahead and make that fancy, we go to our overrides. We add a field override returned by a query, option B for humidity. We're going to add that override, and we're going to add units of measurement, and we're going to go with percentage, and it's going to be 0 through 100, I believe. I lied. Excuse me. All right, there we go. So now you can see we have two different axes here. We have the left axis that has the temperature. We have the right that is hosting the humidity. Could those be on the same scale? Probably, right? So as we add more data to this, we're going to go ahead and play with these axes to make it so that it looks better and it's easier to follow. Okay, let me check the chat real quick. Okay, that's the developer I'm working with. All right. So, all right, we're going to go back to this. All right, we're going to continue to add some more data to this. The next thing that we're going to add, and we only got a couple of things here. We only got temperature, excuse me, humidity. We're going to add mass. Let's go. Flower 1 is the sensor node. We're going to go straight to address. And I would like to start pulling in. This is going to be a problem. Okay, there we go. I guess since I know it's in there, I can just do that. Okay, so we're going to go to the radiometer. Okay, and field value for that one is going to be sensor degrees Fahrenheit. That's the actual value of the sensor. The apogee radiometer gives two temperature readings. It gives the average reading from the aperture that its main site is looking towards, and then it gives the actual reading of the sensor itself, its own body temperature. So in a way, it's also providing a secondary calibration point for temperature in the room. So you can always have two different points. I just spilled coffee on myself like I don't know how to drink. Okay, so 600 degrees Fahrenheit, we want that in there. And we're going to go with room temp 2, or room temp number 2, okay? Because that's essentially what that is. Now, we're going to go ahead and add another query. And go with the radiometer again, and this time we're going with we're gonna have to go through them here. It should be this one. And leaf surface temp. And we're gonna test this now. Apply it, wait for it to pop up, and see if it populates our values for us. Make this bigger. Sexy now. Ooh. So now we have our room temp number 2 and leaf surface temperature. Yeah, buddy. See how this is starting to come together? You just wait for it. You just wait for it. All right. Now we're going to edit this some more. Let's do this. Okay. So we got leaf surface temperature. We're going to do query, select measurements, address. It's going to be R, and I think I don't know if he added VPD in here. Yeah, like he was supposed to. Excuse me. All right. Anyways, we're going to skip that one for now. We got leaf surface temp here. We'll calculate the VPD later. All right. We're now going to move on to the par meter. And the values we're going to select here that we care about is going to be total ppfd. Add another one. And it's going to be far red percentage. And we're going to save, and we'll see what happens. Bow, chicka, wow, wow. Bow, wow, wow. Bow, bow, wow. All right. Gucci Coochie, we got all that in there. It's loaded up. It's looking good. Data is flowing. Ooh, yes. Oh, yeah. This is going to get sloppy. I've got to do some quick cleanup work on this. So we've got a whole bunch of different axes going on. Let's make sense of it. So we are going to come over here on the right. These are the standard options right here. We should reduce these. These are all standard options until you get down here where these say override. These are override options, okay? So in our standard options, we could choose unit. We don't really need to because everything is going to have its own unit applied to it for the most part. But we do want, excuse me, the minimum to be 0. And the maximum is going to be whatever the fuck's going on, okay? We have a soft minimum, of 0, and we're not, like I said, not applying any, how did I get there? We're not applying any units. Okay, so now we're going to add some overrides, and we've got our override for query A and B already, and we're going to add some more now. So query C is degrees Fahrenheit, and we'll just go ahead and choose this, choose C, override, unit, Fahrenheit, done. We'll have another field override, we'll go to D, and we're going to probably add additional overrides to these all, but we'll get there. So D is going to be leaf surface temperature, and that is also going to be in Fahrenheit. And then E here is the total ppfd, so we're going to add another one. And its total ppfd, it's going to be unit, and it's going to be in excuse me, umoles per meter squared, I think. Let me see, where's it at? I want to make sure I type it right. I always fucking type it wrong. Toast, vapor, atmos, far red. There it is. All right. And then F is the far red percentage. So we're going to add one more. F unit percentage. Apply. Change the color here. You can even go custom if you want. For me, far red, I like to make it dark, 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 like that. Okay, then we got total ppfd. For me, that represents the sun, my yellow. Leaf surface temp for me is always green. I want to know what the fuck is going on with my canopy. Excuse me. Room temp for me is fine, being like orange to yellow, or even sometimes light blue, but you want to be able to differentiate it from the yellow, right? So we'll go with this orange here. Relative humidity, that's my blue. And room temp, orange. Okay, so now we have some colors assigned here. We got some stuff looking good. And now we're going to do some mode. So I see a few things that can be changed. Personally, I like to see majority of the statistics on the right-hand side, and then whatever is going to be the most constant or the least pertinent over here on the left, because it disassociates it from the graph. When you have it over here on the right side, right next to the lines, it's very easy to associate what you're looking at with the values. So we're going to modify this a little bit and make it a little bit easier to read and make a little bit more sense. So we're going to go back into edit, and then we're going to go to override, and for far red percentage and PPFD, those are going to be the ones that are going to be like way out of whack compared to what the rest of the readings, right? Majority of the other readings that we get are going to be in the value range of 0 to 100. You have your Taros 12s, your Atmos 14. The only ones that are really going to skyrocket out of that zone, excuse me, it's going to be like the PAR sensor. Even the radiometers can stay within 0 to 100 most of the time. So, why did I go like this? Like this was a mouse. It's not a mouse. So what we're going to do is we're going to put all of the values pretty much on the right-hand side with the exception of a few, okay? And the way that you do that is like override 1 is for degrees in Fahrenheit. So you can add this, and we're going to add axis placement right. Gucci coochie. Done. And then we're going to go on to the next one. Override 2, which is the relative humidity. It's also going to be from 0 to 100. We can add that on the right. Override 3 in Fahrenheit, also going to be on the right. You guys get this? It's super easy, right? Override 4 is also Fahrenheit. We want that on the right. Now, it might seem like there's a lot that goes into this. There is. We want our PPFD values on the left. This one is going to be override 6, field F. What are you? F, F, F. Excuse me. For our red percentage, you're going to be on the left. And then override 7, far right percentage. Wait, didn't I just do that one? What's this one? What's 6? F, far red percentage. Override 7. Oh, those were for the colors. Okay, yeah, that's fine. Not worried about those. I was like, what the fuck are those? I didn't make those. Okay, on the left. I'm going to save this. I'm going to check it out. Oochie Goochie Coochie, baby. Now you can see here we've got a pretty looking graph. Now, here's something that you need to be mindful of. Hold on. Come on, man, knock it off. Stupid ass little dog. All right. So, one thing you need to be mindful of is when you have values like far red percentage, that value is going to be super, super, super low, right? You're going to typically have values between 0 and 10%. When you're looking at the other side of the coin, you're going to have values as high as 100. So it's going to be very difficult to put those on the same scale, right? But if you look here, it's scaled on its own, right? So far red percentage is now from 0 to 10 on this whole thing. But over here, you can see we have 0 up to 100. So it scales differently depending on what you're measuring. So over here, you can see far red percentage. It's not at 70% like it is on the right. That value is over here on the left. It's at 10%, a little over. Okay. So, um, pay attention to where you're keeping your metrics and where you're referring to them at, and make sure that you add the correct measurement values and units to the actual readings. So that way, as you're skimming this, you can see. All right. So we've got a lot of data on here so far, and we are not done. We have 6 more sensors to add, okay? And at this point, you have to ask yourself, how do you organize your data in a way that makes sense for you? Does it make sense for you to have one big graph where you plot all of your data from the same room on that one graph? Or do you break it up? And do you do tables? And so each graph represents one table. Now, for me, I have 6 Taros 12s. Personally, if I was doing a one strain per tray grow, I would just take the average of 3 sensors across one table and put them together to create one value that gets presented on the graph as an average, right? Then I would just set up an alert on the individual value of each sensor so that if either one of the three dips below a certain point in water content or dips above a certain point in pore water EC, you can get alerted. That way, if the average reading is still good, but one of them is the oddball and it's not working well, it's drying up too fast, etc., you can still be notified. You're not going to get fucked over because you're looking at an average value, right? However, in the current grow, I don't have monocrops going on. I have 2 different phenos on one tray. I have 2 different phenos and another strain on the other tray. So it's like, for me, I need to capture the individual data from each of these strains. So I would want to add them all, and not average them. So it's just something to think about how you coordinate your data structure, so that you can make sure it's efficient when you're visualizing it. Wendy, you can have as many graphs as you want. So that's the thing. So check it out. Right now, we're just creating one panel called Flower Room. If I wanted, I can create a whole nother panel and we'll just, oops. We're going to go with Taros 12.1, and I want water content percentage for rock wool. UWC percentage, apply, edit, panel options, flower room, right tray, save. Okay, so now we have left tray and right tray. I could literally, watch. Let me show you how I would do this. This is a real demo right here. So we're going to go to more, duplicate, edit, right tray. This doesn't have any of the Taros 12s on it, but it has all of the data from the other sensors, which is all shared. So now I can just add my Taros 12 data for the right side of the room, which is Taros 12, 1, 2, and 3. So I can do select measurement where address is 1. Field value, let's go with pour water EC. Pour water EC. And then we're going to add another query. And we're going to go number 2. Or no, we're not done with number 1. And we're going to go with water content for rock wool. Am I on the left tray or the right? No, I'm on the right. Okay. And then that's Taros 12 number 1. I'm going to do the same thing for number 2. Yo, I was about to fuck up that chart right there. But you get me? So this is how it works. So we got for EC from address 1, we got volumetric water content from address 1. That's all we need. I could get the temperature from those cubes, but right now I really don't care. And now we're going to go to address 2. Pour water EC, and it's Teros 2, pour water EC. And this one was Teros 1. That's 1. Metric water content percentage. And then we're going to add another one. You guys having fun yet? I know this is fun. I know it's fun. Don't lie to me. This is what I do all night in my dreams. I just live, eat, breathe, shit. All of this. That's number 2, and we're gonna do one more. Number 3, pour EC, Terra 3, pour water EC. Stop it. Okay. Why did that not say? Alrighty. Save, apply. Now look, now we have Taros 12. 1, 2, and 3 all showing up on here. Look at the last values here. 3.4, 3.6, 3.6. That one's 73. It's a little overwatered in front. So now we're seeing all this data coming in. And then it just becomes a matter of, again, how do you want it to look, making it look right. And you can hide these, you can move them around however you want. So if you wanted them not side by side, they don't have to be side by side. You can put them one on top of the other, So here you go, they're stacked now. And then you can bring this one back over. You can organize them literally however you want, drag and drop them, and all the data is right there. Now, let's say you don't like this format. It's too crowded or whatever, and you want to hone in on certain information. You can do that. You just select the data that you want to see, and that's it. You can turn them off. You can hide them. You can make them clear. You can do whatever you want. Another thing that you can do if you don't like the way that this is formatted is you can move that legend over and you can put it on the right if you want, and that changes the look dramatically. Especially if you were to get rid of some of like the min, max, and mean and just have like the last and the mean value. Now you can see how it starts to make a little bit more sense. It looks a little bit different. You track things a little bit differently this way, and I don't have everything on right now, so there. Now, we didn't set any of these up with units, values, or axes yet, but once we do, it'll correlate to some of this information that's over here on the right, and it'll make more sense. But you can literally track every fucking thing in the room with this. Set it to refresh automatically every 5 seconds. You can refresh it when you want. And that's basically it. loading all the data in, and there's a bunch of, other tips, tricks, other ways to visualize the data. Um, it just depends on what you want to do with it and how you want to see it. No, this is not off of Home Assistant. This is 100% custom built firmware. Oh, frozen. Awesome. So hopefully that explains, the graphing a little bit and pulling data into the system. Um, you can take everything another step further as far as the data representation. You can create bar graphs, all different types of charts and graphs. And then you can also go in there and set up alerts that work for, like I said, minimum water content, maximum pour water, EC, things like that. You can set up these alerts and have them set up as either SMTP alerts where it sends you an email, or it could be uh text message alerts, all types of stuff. So yep, this is all 100% custom. No bullshit Home Assistant. There's no Raspberry Pis being used. I got a lot of criticism that I was going to be using like some Raspberry Pis in a box. Yeah. So I'm going to save this video, make it available for my patrons um, to go back and rewatch as much as you need to. Um, and then we'll go ahead and do another one of these sessions probably in a couple days, and I'll go over my final dashboard for my room, how it's going to be set up. Um, the methodology that I take for exploring my data is looking at it from both the sea level view and Mount Everest view. You have to be able to look at the data from different perspectives to draw conclusions and trends. So if you're always looking at a 24-hour time frame, you're going to see 24-hour trends, but you're not going to see the day-to-day trend, right? So being able to zoom out time wise and zoom in time wise is very critical, and you can do that here. And then on top of that, excuse me, I'm trying to catch my breath here. On top of that, you can go in there and say, I only want to look at this sensor on this side of the room, like the Teros 12s on the left side of the room, and the temperature. And that can be one separate graph. So you can create all these different graphs to create these different correlations between data points. So that way you don't have to look at one big clusterfuck of a graph with all these different data points on it. You can break it down into smaller bites of information that are easier to digest and might be a little bit more meaningful at quick glance. Any questions so far? I feel like you guys are awfully quiet. So one of the values, I'm gonna pull my screen up in a second and share it with you, but I gotta find it real quick. Man, or address, model, or vendor. I want to know where my leaf VPD calculations went. I don't think he added them back in. So when this comes out, there's going to be leaf surface calculations in it. I don't know where he put them because they were honestly already in here. We were already doing real-time VPE. Um, it seems like maybe the latest code, it was left out. So we'll have to get that added back in, and then we'll be able to present real-time leaf surface VPD. So that's going to be calculated using the infrared radiometer and the Atmos 14. You doubt it's not anything I haven't thought of already? Well, shoot, man, you never know. I might have missed some stuff. So I'm all ears. What's up, Indy? All right. Well, dun, 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 dun. All right, well, let's try and choke down another dab, and we'll end the daily dab like that. Short, sweet, to the point. How long do you keep the data for? Like forever? Are you ditching it between runs? Good question. So the default data retention policy is for 1 year, 365 days. That can be changed. So what you can do is you can save up your grow room data for a year and then dump it all into a backup drive and then refresh your database. Leaf angle measurements, for why would we want to measure the leaf angle? How would this system be used to control? Well, when we're done importing the control modules, the brain, which is the Linux server that has the database on it, you'll be able to open up a web page and utilize that web page's interface to control or speak to the various wireless control modules that are out there and issue commands that specify what you want them to do. And then as we develop further into the project, the control modules will be able to be triggered off of sensor values. So, turn on this outlet for whenever this sensor value gets below this. No, I don't want to gather useless information. I think leaf angle is not a very useful metric. We have leaf surface temp, and I think we're going to be looking at other things that are a little bit more high end because the system is called Pinnacle for a reason. It's going to be the best thing out there. Period. That's I'm not building it to be anything less than better than what's out there right now. So Um, I'm gonna make it too easy for everybody to grow weed. Yeah. So I'm looking into very, very high-end sensors. The stomata conductance sensor is a very big one. It tells you how efficiently your stomata are opening and closing, which is a direct correlation to how well the plant is photosynthesizing, and how well it photosynthesizes, determines how big it grows, how strong it grows, and the fruits and the bricks level and all that. So, as far as availability, I know I've been getting so many questions as far as when is it going to become available and what's the price going to be. And so I wanted to share it with you guys because we have gotten some, information as far as how much it cost us to build the sensor node right now. That doesn't take into account the, custom enclosure that we're going to be getting for it. This is just a plastic enclosure, but when we go to the custom full metal enclosures, there might be some additional cost. But um, right now, the way that it's priced out is the brain module, which is what hosts the database. It has our firmware and software, and it has Grafana on it. That's looking like it's going to be probably around 2,500 bucks. And then the sensor node, which is this here, where you actually plug in your sensors. You can have up to 10 sensors plugged in, and it talks wirelessly back to the brain. This is going to be probably around 1,500 bucks. So, those of you guys that are growing in tents or whatever, you might say, well, damn, that seems expensive. But you could literally control fucking 2, 3 tents with one sensor node. You know what I'm saying? Um, 2 Teros 12s and 3 tents is only 6 sensors. You put an Atmos 14 in each one of those. Now you're up to 9. Boom. You're at 9 sensors and you have 2 Teros 12s and an Atmos 14 and 3 different tents, all with one sensor node. So the value is definitely, definitely there. And I know that other companies charge almost the same, if not more, and they don't bring the same level of capability and expandability. Um, you can plug as many sensor nodes up to one brain as you want. On the website, I put up to 99, but you can literally put as many as you want. I mean, as long as they're able to grab an IP address and be on the same network, they can talk back to the brain, and the brain can have as many connections as it needs to, and it just all the data piles into that one server. So big facility growers that have um, multiple multiple rooms, they can have one brain unit control the whole facility and just put one of these or two of these in each room. And here's the really, really dope part. Let's say you have a facility in California and you have a facility in Florida, two opposite ends of the world. You can access the logs and the sensor data from one site at the other through the internet. That's dope. Now you can log in California using the same brain. You get me? So if you were to deploy one of these in your facility in Florida, it doesn't need to have a brain with it at that facility. It just needs to have a brain that has internet access and it's configured in these settings. And this will talk out to the internet, back to your brain, and relay the information. Okay. So, California owner buys the brain and a sensor node, deploys it in their facility, sets it all up, sends a sensor node over to their Florida operation. They hook up their shit, and guess what? Now it's talking back into the same database, and you can access the information from a central location. That right there is huge. You know, not not many companies said nice. So would it be IoT relay triggers? Any specifics on type of relays that will or will not be supported? I wish you would ask me a more direct question like, are you going to support this or are you going to support that? It's a very difficult question to answer the way that you worded that. Pinnacle is set up so that we can support anything and everything, and we can build a module to support everything. I'm not the hardware guru when it comes to circuitry and design. That's why my developer is working with me. So maybe that's just a question that's a little over my head as far as the types of relays and whatnot, and I don't know how to answer it. So if that's the case, my bad. But as far as what it can control, everything. It's a computer. We can control it. We can code it to do whatever we want. Um, So it's just a matter of, hey, here's a new sensor or relay or a switch that is in high demand for having support. We get enough requests for it. We develop the support for it, roll out the update, and now everybody has access to that sensor or relay control module or what have you. So yeah, that's the system. Keep the questions coming. Good questions. What's up, Winston? Mike C. He's in class right now. He's not going to be able to answer. Gonna need that crop salt starter in a couple of days. Do I owe you crop salt or something? Oh man. And when you say it like that, it makes me think I missed your order or something. Did I miss your order? You have an order in with me for crop salt right now? Excuse me. Okay. I gotta go to my dashboard here. I'm gonna share my screen with you guys real quick. Again. So see how I got this right room done and I have Taros 12, 1, 2, and 3. If I wanted to make a duplicate of this panel, um, what? Huh, okay. I'm gonna go punch my kids in the face. Okay. Okay, so this has everything on it. This is the right room. the right side of the room. We're going to go to more and duplicate and then check it. We already have all these sensors in here, and I am a cheater. Let me show you how. Cheater, cheater, pumpkin eater. Where it says 1, we're going to change it to 4. Where it says 2, we're going to change it to 5. And where it says 3, we're going to change it to 6. And now we're done. I don't know why this is here. This is doing nothing. Save it. Apply it. Bah. And then we got to go to edit real quick because we do need to change those names. I forgot. So Taros 4, 5, 6. Apply. Left tray. So now, look, we got the right side of the room with Taros 1, 2, and 3, temperature, humidity, blah, 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 blah. And then we got the same exact thing, but for the left side of the room using Taros 4, 5, and 6. Gucci, Gucci, Gucci. Gucci, Gucci, Gucci. Again, this data is not useful. In my opinion, there's way too much data on this screen right now. If it were up to me, I would eliminate some of this data here, but that's just me. I would keep my pour water EC and my volumetric water content, but I would probably do these like complementary colors. So like Taros 4 could be this red and this red, so that I see them together. You get me? Or you can even make them the same color if you wanted. And in this one, let's just say we're going to do the perps. So now those are kind of similar. But, you know, it's up to you. However, it makes sense for you to correlate the data. That's what's most important. Like I can make Taros 12, both values, pour water EC and volumetric water content purple. So I know, hey, that's that Taros 12. For this one, I can make them fuck it, let's go blue. So I typically like to do blue. And then Taros 12, 6, let's go with green. Okay, so now we've got some, you know, shit that we can correlate here. We got, and we'll make this one light. So now you can see here the Taros 12, 6. Let's zoom this. I want to make this go back to the bottom. I don't like it on the right. It takes up too much space of the graph. All right. So we got our relative humidity up here. And then we got our volumetric water content. So yeah, I would break this down. Me personally, when I did it, like I said, I had the 3 Taros 12s and then temperature, humidity, and BPD basically. Any idea if something like that can be integrated for control? I literally just explained how the system is going to control stuff. If you missed it, please go back in the video and rewatch it because, wow, why is this still freezing so much? I don't know why I keep freezing. Floraflex is trash. Anyways, yeah, yeah, that's fair. All right, you guys. That's it. It looks like all the questions on the Pinnacle system died down. I'm gonna keep this video kind of on point and call it a day. But thank you guys for hanging out and stay tuned for more information. The Patreon is about to start getting fired up now that I have these data points coming in. So all the Patreon members are going to get access to my dashboard so that you can log in and view this for yourself. And yeah,